make one note that the level of difficulty of this webinar or workshop is going to be slightly medium to advanced. It's not going to be super easy, but I hope everybody will be able to follow because we'll take the time to do so. And the reason it is a little bit advanced more than what you may find in other workshops if you have ever attended is because I really want you guys to learn something from this and not just sit through one lecture and then forget all about it. So in an effort to do so, what we will do is we'll do a bunch of activities like Rohit sir said, we will build games, we will build animations, we will solve problems together, and it'll be quite fun. So we'll explore a lot of what Scratch has to offer, and let's just dive right into it. And again, like one short note before we get started about myself. I have been coding for 12 years now. Most recently, I head engineering of a very large startup that is based out of Noida, and I run the India center of that US-based startup. We have 40 to 50 people in our India office, and I run all of the engineering for that software company, which does security automation and security analytics. So that's a quick intro about myself, and let's get started right away. All right. So a quick glimpse at the agenda. We are going to learn two separate things. We are going to learn about Scratch, and we are also going to learn about coding concepts. So we learn how to build things in Scratch with a focus on understanding Scratch, Scratch interface and Scratch blocks and all the elements that are there in Scratch, how to use Scratch, become quite proficient at it. And as a means of that, we'll also learn a couple of coding concepts, which remain constant no matter what coding language you're using. So irrespective of whether you are learning Scratch or you're learning Python or you're learning Java, these coding concepts will remain the same. That's why if you learn your first coding language, even at an easy level, it is very easy to pick up any other second language or third programming language. Okay. So let's briefly touch upon what is coding, because I promised that there is no prerequisite. You can come into the webinar knowing nothing, and we will start from the very, very beginning. So what exactly is coding? We know that around us, computers do almost everything. In the last workshop, we saw a video of how now we have computers inside our brains also. So we have the technology to be able to run a computer without even touching a computer, simply by thinking about what we want to do. And everything is done by somebody, some software developer actually coding behind the scenes on a small laptop. So that's how all the magic is happening. So what exactly is coding? Coding is the activity of writing a set of steps or set of instructions that tells the computer what exactly do you need to do. So you have to be very specific while writing those set of instructions, because computer is essentially a dumb machine. It will do exactly what you tell it to do. So that is what is coding. And why do we need to learn to code? And is it relevant for very young kids? Is it relevant for a 5-year-old? Is it relevant for a 40-year-old? Well, so coding is not just about if you are an engineer, it's useful to you. Now, coding has evolved to become a core skill set. In about 10 years, most of the jobs will require you to understand coding. I'll take a very short example. Yesterday, a student of mine who is in college, who is going to pass out, student as in I mentor that student, he was sitting for his job placements. He's from Thapar. And he was interviewing for a consulting company. It's a consulting firm. And yet in the shortlisting round of that consulting firm, they were asking coding questions. And he was asking me, how do I prepare for it? Because I know nothing about it, because he's not from the computer science branch, right? So even for unrelated fields, nowadays coding has become an essential skill set. And if you are starting after you have finished your engineering in a college, that's very late. Why should we do so? Why can't we start as early as possible? So coding allows you to build a builder mindset instead of a consumer mindset. Instead of sitting on the laptop only watching YouTube videos, what the kids can do is they can build and be creative with it. Pretty much like you hand them colors and a drawing pad and they can build anything. So please replace that with laptops and you can see how they can become much more efficient, creative, and learn fruitful skills that will be very, very helpful in the future. Secondly, it is, as we will see when we go through these activities, it is 80% problem solving. It's almost like solving a puzzle. You think of a problem, you have to have very structured thinking, how to approach a problem, break it down into tasks, and then translate it into code. And something will not work, you have to go and iterate, and you have to figure out what are the problems and solve them. It also boosts creativity, again, something we will see in our activities. It's not just about, if you are able to do calculations very fast, you will be good at coding. Absolutely not. You have to be very creative when you have to code, because the more important part is, what do you want to innovate? What do you want to create? So that is very important. And the fourth part is definitely having a lot of options career wise later on in your life, and high earning career. All of us work 8 to 9 days every day, 8 to 9 hours every day, 5 days a week, right? So if you have the option of earning more by developing a particular skill set, that's very helpful. And I'll tell you that nowadays there are so many new companies that come into the market, and in 5 years they become bigger than even technology giants that have been around forever, or even like manufacturing giants. For example, WhatsApp, that all of us are very familiar with. Do you know that it was acquired by Facebook? So Facebook paid 20 billion US dollars, which is about, I think, 1 lakh crore rupees. And it was built by only 50 people in 5 years. That's it. And Infosys or TCS, I think, is about like 4 lakhs of people and only 4 lakh crore of total value. And they have been around forever. So only 50 people did the job of what 1 lakh employees did. That is the kind of power coding has. So somebody said it, the video has stopped. Is everybody able to follow along? Is my video and audio working fine? Just a quick check.
Yeah, to me it's fine.
Okay. We'll keep going. If there are any glitches, let me know in the chat. All right. So we understood what coding is. There are many, many programming languages. I'm not going to go through the list of this, but there are different kind of jobs. And the idea is that for every different kind of job, you have to learn a different kind of language, but the concepts remain the same. So when we learn Scratch today, by the end of this 1 hour, you would have learned majority of the concepts that you would require to learn any of these languages, no matter what the language is. And it will be very easy to understand. All right. So these coding languages, the one primary difference is these are slightly advanced, right? Because you need to write instructions. You also need to remember a lot of instructions and how to write them and complex statements. So what some folks from MIT, they thought about was that, can we build it in such a way that you are only concerned about what do you want to do instead of remembering all of these instructions, which are so hard. And also, if you have to write such long sentences, remember such instructions, our kids are never going to enjoy it. It's going to be so boring, right? It's going to be very boring. It's going to be very hard. A 5-year-old can certainly not do that. They can barely read sentences. Okay, so what they designed was, they designed block-based programming. It's basically a visual editor where you have to remember nothing. You simply have to drag and drop blocks, like you basically do those puzzles where you join the pieces and make a picture, pretty much like that. So as soon as they did that, what happened was it became magical for kids. It became like a game for kids. They could think of things, imagine things, and they could build it. Without kids who were not even able to write languages properly or write sentences properly and read advanced English properly, were able to do programming. So that's how early you can introduce coding as a hobby to kids using block-based programming. And that's why Scratch is so important for all of us educators to know and understand. So that's a little bit about coding and block-based coding, what block-based coding is. And one of the most popular block-based coding programming languages is Scratch. There are multiple of them, and Scratch is the most popular one. So we are going to focus on Scratch today. And now from here till the very end, you're simply going to learn and deep dive into Scratch. All right. So it is, I don't know how many of you are attending on your laptop, but if you're attending on your laptop, take the time to just open this link and go to scratchmit.edu, just search for it, and you will see what Scratch is. So from here on, I'll not be looking at slides. I'll be barely looking at slides. I'll be doing a lot of live coding for you, and I'll be showing you around and exploring. We'll be exploring things together. Okay, so you have to go to scratch.mit.edu, and my hope is that some of you, or all of you, or at least some of you, go and create an account, check out the tutorials, and do at least one small activity by yourself. Just repeat the activity that we do today. Even that should be a good goal.
I have shared the link on the chat box. You can click and go there. Yeah.
So I am logged in. You can create your profile. This screen where we land at is known as the dashboard. You can see that there are a lot of starter projects and tutorials in here. If I click here, it will tell you tutorials by means of creating a project. So let's take a look at this tutorial.
With Scratch, you can make your own stories, games, and animations. Let's start by grabbing a move block. We can click the block to run it. There are many other blocks to choose from. Check out the different categories. Let's go to the sound category and grab a play sound until done block. I'll snap this onto our move block. When do we want these code blocks to run? Add an event block on top to start the code. I'll add the when green flag clicked block. You can easily reorder or delete these blocks at any time. Add as many characters as you want to your project and code each one. Check out the tutorials page for ideas and inspiration.
All right. So this was a quick intro. I don't expect you to learn anything. We will do all of this together multiple times today. So by the end of it, it should be very, very easy and familiar. And there are many starter projects also that you can check out. We will do one of these and then we'll create our own. All right, perfect. If you go to my stuff inside profile, here are your projects. So we'll delete these. And then there are a couple of projects and we are going to build 3 of them today. So let's get started, and like I said, it's going to be very interactive and I'm going to do a lot of live coding. So we will dive right into it. First and foremost, I want to introduce you to the Scratch interface. So this is where you code. Where is the code? If this is the coding area, where is the code and what is the output? What is the input? So this block that we see here is known as the canvas, and canvas is our output. So Scratch is mainly a coding language to code sprites because that is how you develop games. A sprite is a character. You can add 1 or more characters. So here is 1 character. I can add more characters if I like. Let's add an apple. So cat is 1 sprite. Any character or an object in here is a sprite. And I can also give a backdrop or a background, which is known as stage. So let's give it, let's put both of them on the North Pole. Okay, so this looks interesting. So every sprite can have some code associated with it. So what we are going to try to do is to do the tutorial, what the tutorial said, just kick it off. So I have clicked on my cat. If you see that this is highlighted, and you can see it here also. I hope my mouse is visible because I'll be pointing to a lot of things. So this means that I am going to code my cat right now. When I say code, I'm going to control it by specifying a set of instructions. So you see, when I click it, it's moving right now. And I did not write any sentences or I did not learn any instructions, and I'm able to code right away. That's the beauty of Scratch. By simply dragging and dropping the blocks. If I click on Apple, the apple becomes active and I can, let's see. So I'm going to be a bit creative and give it a story. So go to random position. Because I coded the apple to go to random position, every time I'm clicking it, there is this one instruction or one step that it is applying to apple, and it is doing as it says, go to random position. If I do go to mouse pointer, let's see what happens. So it's very hard for me to display this. So we will go to sprite 1. It went to cat because cat is named as sprite 1. You can change the name of the sprite here and call it something better. So cat and apple, there are 2 sprites. Perfect. So this is a quick intro of how you can do it, because coding is generally and almost always more than 1 steps because you want it to do something, right? So let's say my apple is here and my cat is here. What I want to do is I want to move the cat to the apple. How will I do it? I can think some of you would have guessed it. I can attach multiple blocks and now it's moving, but it's moving very slowly. So instead of attaching multiple steps, I can also just increase the number of steps. And to remove it, I can simply detach it, or I can, to completely erase it, I can drag and drop it back in the block interface. Okay. So I said, let me drag it back and click on it. Perfect. And it is reaching the apple. Some more terminology. So this is our coding interface. And these things that I'm dragging and dropping are known as blocks. Blocks are essentially, one block is 1 step. These are the instructions. When I put together multiple steps, we are creating a script or a piece of code. And right now I'm clicking each element, but this is very hard to do, right? So there is a run button here. Whenever I click this green button, this is known as the run button. When I click the green button, it will take the action of running all of this. But if I click it right now, you see it's not running. But why is it not running? Because what we need to do is we need to attach a starting block here. That starting block tells it that what is the event. It is known as event block. What is the event that happens when it needs to run? It should not run automatically without any event trigger. There has to be an event which makes this run. So I'm saying whenever I click this green flag or the run button, then you should execute these steps. So let's try it now. So perfect. So if you have understood these points so far, we have learned about 10% of what Scratch is. The rest of it is simply your imagination because it's going to be very, very easy from here on. Okay. So we learned about the event block, very important because it will not trigger by itself, and we learned about other steps. Now let's go back to our PPT and move on. So where are the slides about, detailing about every single thing in here, costume, sounds, motion, looks? There are so many things. Why don't I have that in the PPT? Because that's not how we are going to learn things today. We are going to build an actual, real, useful thing, useful or funny thing. Both funny things are useful also. So we're just going to have fun with coding, and we are going to do activities. And by means of activity, we are going to learn all of the concepts. Perfect. So let's take a look at what is it that we are going to build. So because it's Sunday and everybody is happy, we are going to do a happy dance. That's how we are going to kick off our first activity. Let's see what it's going to look like. So sound is very catchy. I got distracted. All right. So to build this, it actually, it looks very nice, but it requires, most of the instructions it requires, we have already understood so far. I'll give you a couple of minutes by the time like I set it up and I start speaking. I'm going to give you like 30 seconds to think about how would you approach such a problem. How would you, what kind of blocks do you need? Why is it rotating? How can you create this kind of an effect? And see what you think. All right, so I'm going to do it right here. I'm going to keep it here for reference. Listen to a little bit of music while we do that. Perfect. So I hope you gave it a thought as to how would you approach the problem. And that's the first thing you must always do when you are jumping into any coding exercise or any activity, right? Before you step in and start coding, what you need to do is basically think about all the steps. Very much like, for example, when we cook dishes, in our mind, it's very clear that what are the steps you need. Here are the elements you need. So you have your jeera and dhania and haldi and namak, everything. And you have your vegetables cut. Now, you know, you first have to put the oil, then you have to put the jeera, and then you have to put the masala, then you have to put the vegetables. Then that's the order of things. So similarly, when you are going into a coding exercise, this should be very clear to you that what are the steps. So think about it a little bit before you dive right in. So here are the steps. What I can see is, one, we need a background. We need this sprite, which is a crab. Okay, this is very clear. Couple of things are happening as I observed. I noticed that, okay, so it is changing faces. That is one thing that I noticed, and it is moving along. When it is moving, it is also doing like some different actions. If you see that its hands are moving and its legs are moving. So that is what it is doing. Yes, it is changing costumes. So we'll not skip ahead and we will go there, but great job on that. Perfect. So we understand that it is doing some repetitive thing. Okay, so it needs to repeat, and while it's repeating, it needs to move randomly, and it's moving, and it's moving a little bit, then it's changing direction, and then it's moving. It's also changing expression and basically eyes and hands and so on and so forth. And there is some background and there is some music. So now I'm going to dive into it and we will start to code. So perfect. So we'll do the things that we know and we have learned already. So what have we learned already? So we need a background. Okay, water, let's see. Okay, perfect. So here is one. And we don't need this cat. We don't need this apple. What do we need? We need a crab. So let's search for the crab. So here is a crab sprite. So this is good, but then the size of the crab there was a little bit bigger. So I'm going to increase the size. You see this size element? So remember, you can change the position and you can change the size also here. Perfect. So looking good, looking quite similar now. Only the motion is remaining. So first and foremost, I noticed that when I click this, everything was happening. So I'm going to pick my event block, which is when the green flag is clicked. Second is I'm going to put some motion in here. So let's see. So if I keep moving, it's going to go out of the screen. So we don't want that to happen. So I must change direction. Is there a motion block? Can I move it somehow? Is there a blue block, which is a motion block that will help me turn? Okay, so let's try this. So it's moving a little bit and it is turning, but the other crab was not doing so. So what must we do? So here are few interesting things that you will have to learn and you will remember, but it's very easy. So it's not a difficult thing. What I want is I want the crab to change direction. I don't want it to rotate. Rotate as in घूमना नहीं चाहिए. It should only just go from one place to the other. So for that, what we can do is we can set the rotation style to don't rotate for the sprite. And then let me see what it is doing. I'll increase the steps a little bit so that it is okay. At least it's not moving. Something is happening. See, if I click it, it's going around in circles, very much like the other crab. So we are getting closer. So this is good. But you know what? You click the green flag once and it was doing it automatically. And I did not have to click it multiple times in the other one. So how can we do that? You can intuitively understand that what we need to do is keep doing this again and again repetitively, right? So what we can use is basically something that is known as a control block. So it's very easy. You don't have to remember the names. You can simply think about what you need, and it's very straightforward because the language is very easy. If I say repeat 10, let's see what it does. Okay, perfect. So at least I don't have to click 10 times. Repeat 10 simply means if I would have clicked it 10 times, it does the same thing. So instead of me clicking it, it will repeat the same set of blocks 10 times. But I don't want to do it for 10 times, maybe like 1,000 times. Okay, this is good, but it is still going to stop. Is there something that I can use so that it will never stop? So as some of you might have noticed, yeah, there is a forever block. It means that keep going on forever. Don't stop. I'll delete this one. Let's see what happens. Awesome. So far, so good. Getting very close. So now comes I can click the red button, which is the stop button to stop it. Now comes the interesting part. How can I change the expressions? So here we will learn something interesting, because generally in animations, or let's say if any of you have played Subway Surfer or Temple Run, it was very popular a couple of years ago. As the boy is moving on his or let's just take the example of Temple Run. As the person is running, there are a lot of motions that he does. There are expressions, the person jumps, etc. All of that is codified. And what that is known as is costumes. Costumes is nothing but different expressions of this sprite that you are going to use in different situations. That's it. So I am going to create some crazy, as you see that there are two of them, but they are not very different. So I'm going to change it a little bit and just make it a little bit more fun. So you can create your own costumes very, very easily because there is a paint editor already in here and it's very intuitive. So simply just give it a shot and you'll be able to. Let me give it a smile. Okay. And we don't want to be very creative. I mean, with my drawing, I don't want to be very creative right now. So I can also choose a costume from the costume library, or I can create my own. Right now, I want to create my own because I want all of them to be very similar to this crab. Okay, so let me add a couple of them. All I'm doing is I'm copy pasting it. So I copied all of it and then I pasted it. So now we are going to modify it. So I will make it a little bit funky because there should be some creativity, something different that we must do. So let me make it a colorful crab because why not? Okay. I'll just change some expressions. I'll pick the black color. Okay, perfect. So I think 4 of them are good enough. Now let's see how we can use these different costumes. So if you remember what our objective was, what we want to do is after a little while, it should change costume. So I think that's okay. We can simply change it here. If we have a change costume block, I think we are pretty close to done. So switch costume. to switch costume to costume 2, but here I have to select, I want to take the next one. Is there something better? So there is a very easy block. It is known as next costume. It's just going to pick the next costume. So let's see what happens. Okay, perfect. It's a little bit crazier than the other crab. So what I want to do is I want to introduce you to a very, very useful block, which is the wait block. So whenever we want it to slow down because we can't deal with so much energy, what we can use is the wait block, and it will slow down a little bit. You see? And this is basically not enough energy. So, okay. So I think this looks good. So my colors are a bit off, but we get the idea. So we'll not aim for perfection right now. This looks like a crazy crab, crazy dancing crab, looks happy enough for us. The only thing left for us to do is to add the nice music. So where is the music? There is a great sound library in here that we can use. And I wanted, I think it was a beatbox sound. Yeah, I think this is good enough. We don't need this, so we are going to delete it. We'll come back and let's play the sound here. Okay, so this is close enough, but not quite. So there is one change which will also introduce another example, another concept that is very, very important. So you noticed how we have been putting blocks together inside one when clicked, when run clicked event. It is not necessary that you have all your blocks under only one single this item. So the reason I am introducing this new concept wherein we can use multiple of these, and all of these actions will start to happen automatically simultaneously, is because if you see, our music needs to be continuous and our crab needs to move at a different rhythm and our music needs to move at a different rhythm. So what I'm going to do is I'm going to remove play sound from here and put it under the other one. Okay. So what is the mistake here? The mistake is that it's only playing once. We need it to play forever. Very simple. Okay. So I think we have finished our first activity. It's not as close, but that's for you to do as a take-home exercise of how do you make it closer to the one that we saw there, or better, right? Maybe you have to use a different music and you have to use different kind of expressions, fix some of the mistakes, but close enough. Right? Close enough. So we'll pause here and then if are there any questions that anybody has, so I am happy to take some questions at this point. Please do share in the chat at this time that are you able to follow so far, because we have learned a lot of new things. Perfect. Awesome. Awesome. So what did we learn? Very quick summary. We will go to our PPT and we will summarize what did we learn. We learned about sprites and backdrop. I think everybody say a yes if you understood what a sprite is. It is the characters and the objects that you can code. Backdrop is the background. Perfect. Blocks and scripts. We learned a lot about it. So blocks are each of those tiny little steps that you pick and put in the coding area. And script is the set of those blocks all together. It is known as script. When you press the run button, the script runs. When you press the stop button, the script stops. So there are many different block types. We learned about the event type. We learned about the motion blocks type. Motion blocks, very obvious to understand. Motion means moving. So anything related to moving, changing direction, etc. is the motion block. We learned about event block. When should your script run? That's what an event block is. We learn about so many different kinds of events later on. And looks and sounds. We added music. We changed costumes. So looks means changing costumes of a sprite. So This, by the way, is a lot that you have already learned. So I think give yourself a pat in the back if you're able to follow so far along. So there are a couple of questions. I hope set rotation style need not to be given inside forever loop. I think I'll just pause for the questions right now and take them separately later on. But I'll definitely get to that. We will have to do it after the session has ended, because there is so much more that I wanted to share with all of you. All right. So now we will move on to a few other more complex concepts in coding. So if the previous activity was level 2, maybe this one is going to be a level 4 out of 10, not out of 5. Level 4. So still easy, but a little bit more hard than the previous one. Let's see what our objective is. So what we just built is known as animation. Fun fact, I can actually copy these animations anywhere in the website. So if you build something on Scratch, you can take that, you can put inside any website or any presentation also, if you make presentations for any classroom lectures. So this is our second activity. So the first one was animation. The second one is going to be a game. So I was thinking about what game, and I couldn't, like, this is the simplest one that I could think of. So what we need to do here is that we need to click on the balloons to burst them and get some points. So there is one interesting thing that is happening. If you look at the scores, you might be able to see that what is that interesting thing. So I'll break the surprise. So what our activity that we want to do is that obviously we want to create balloons on the screen that when you click on them, it bursts and you get 1 point. So what needs to happen is that for every blue balloon, the blue balloon needs to be smaller so that it's a little bit more difficult, and you get 2 points. Yes, somebody got it right. So great observation skills, because it's not very obvious. So if you click on the blue balloon, you get 2 points. For yellow and other color of balloons, you get only 1 point. Okay, so this is our exercise. This is the small game that we will build. So I'm going to create from scratch. Everything we'll do from the starting, except for the last few activities, because we are short of time. Perfect. So from the starting, we'll do the simple things first. And even before we do anything here, what is it that we are going to do? We have to do something before we even come to this place. What we need to do is we need to think about the steps of how we are going to approach this problem, right? So I'm going to open my activity one more time. I'm going to stare at it. So if you have ever looked at software engineers in your home, you would have looked at them and you would think that why do they keep staring half the time, and half the time they are coding? It's because they are thinking about what to code. So it's as much a thinking job as it is a typing or coding job. Okay, so we are going to think about how we are going to approach it. We are going to analyze it. So the first piece is simple. It needs a background. Good. It needs one sprite. There is one sprite, which is a balloon, and it is changing colors. It is changing costumes. So it's not multiple sprites. It's just one sprite, and we are changing the color of the sprite or the costume of the sprite. There is a new concept. There is a score, as I can see, and we need to increase the score. But there are a few things that we already know. So I know that I need a sprite. I know that I need an event such that when I click on that sprite, it should move. So we know move. We had seen move random. It's randomly moving. That part I know. I have not done how to move it when somebody clicks on it. So hopefully there is a block for it. So far the algorithm or the steps in my mind is that when somebody clicks, I need an event block called click. And when somebody clicks, I need to move it to a random place. So we have not learned about how to keep a score. This is another new concept that we will learn now. Okay. So we know that we have to keep something called a score, and we have to increase it by 1 if it's a a yellow balloon, and by 2 if it's a blue balloon. All right. So I have been pushing you guys to think about the steps before you do any coding, and that exactly is known as algorithm. So algorithm is basically you have a problem, and to break down the problem, to think of a solution and in smaller, simple steps. Okay. Basically to think of a solution in plain English language instructions. So forget about coding, remove the solution part from the coding part. That is what is known as algorithms. Okay. A step-by-step solution to a problem in plain, in any language that you would think, but not in a coding language. For example, and we use algorithms every single day for everything that we do. For example, if we have to wash clothes, what are we going to do? We have an algorithm in our mind without even knowing it. We have an algorithm for almost everything. Okay. So we know that there is a step number 1, put the clothes in the washing machine, put the detergent, set the washing cycle, start the washing cycle, take them out, and then put it to dry. So that's the algorithm for washing clothes. And if just for this today Sunday, if you observe how many times you have these algorithms, small algorithms in your mind for every basic thing also, you can never forget what an algorithm is. It's all around us. Okay. So coding is very universal. You code machines, but we ourselves as humans are also work in a very codified manner. Okay. So before writing code, always lay out the algorithm first in your mind or on paper. Perfect. So this is the algorithm for this one. We will we'll pick a balloon sprite, set a color, and then if the balloon is clicked, play a sound, increase score by 1. If a non-blue balloon, if a yellow balloon is clicked, play a sound and increase score by 2. Perfect. So with that algorithm in mind, let's dive right into it. So I'm going to try and do it very, very fast. I'll pick the blue sky because it looks similar to what we require. I'll remove the cat and I'll search for a balloon. Perfect. Does the balloon, okay, balloon has a couple of costumes already, so we don't have to build the costume. Great. Now, something happens when the script runs, because this is the starting point, so I'm going to pick it anyway. Whenever I click it, what was happening? Let's see. So it was, okay, so it is doing nothing, no matter. I don't need this then. What I want to do is that when the balloon is clicked, so I know that events are when you click on something. Let's see when I click. So there is another thing called sensing. So I'm trying to search for it because I also don't remember where all the blocks are, and that's what you should do also. So simply let's try to see. Okay, so event, when this clicked, when this sprite is clicked. Perfect. Okay, this is what we wanted, and it was located inside events. Logical. When this sprite is clicked, what do we need to do? We need to move it. We already thought about that. So it's going to be go to random position. Let's test it out. Oh, I have to click it. Perfect. And I have to change the costume. Where is my costume? In the looks. Let me pick next costume. Perfect. So far so good. Now there are two concepts that we are going to learn. One, that we want to do something different when the costume is blue. Okay. And we want to do something different when the costume is yellow. And we also want to keep a score. So there are a couple of concepts that we want to learn. The first one is, how do you do something based on a condition? Condition in this case being balloon is blue, right? So if I'm going to speak in English language, I'm going to say, if balloon is blue, do something, otherwise do something else. And I am going to search that if can I find a block that looks something like that. So there is absolutely a block that looks something like that. Okay. So perfect for us. These are known as conditional blocks. If else, you see there are some variety of it. It is different from repeat and forever, which are loops because it does a set of blocks multiple times. And these are conditionals. Depending on a condition, it will either execute one type of blocks or a different type of blocks. Okay. So now what we are going to do is, we are going to say that if the costume is, so how do we do a costume check? Let's see. All right. Let me search for, I need a costume. Okay. So here is what I wanted. Because what is it that I was looking for? I was looking for that what is the costume number? I wanted each of my costumes has a number 1, 2, 3. And I am looking to build a condition. So now we will go and see how we build conditions actually. So building conditions is very easy. I want to check if something is equal to something else. Okay. And then I can pick here. For example, let's 50 equal to 50. We'll do the costume one later. First, let's build our blocks in here. I want to reduce the size, let's say, because my blue balloon was smaller. To reduce the size, again, very simple. Let's look for something that will reduce my size. It should be in the looks. Okay, perfect. Okay, good. So 50 is equal to 50, which is true, obviously. And that is why whenever I'm running, whenever I'm clicking, it is becoming to 50% of the size. If I say 60, 50% of the original size, okay, then it is not equal. So this condition is false. If 60 equal to 50, no, it's not. So it will not run this set size to 50. It will run the blocks inside the else condition. All right. So now let's see if this works. See, change the size back to 100%. So perfect. This is what we need, but we don't want to check two static numbers. We want to check if our costume. So I'm going to put the first number of the check as costume number is equal to 1. 1 is for blue because it was the first costume. Let's see if this works. So if costume is blue, okay, so this is okay. So what I'm going to do is I'm going to cheat a little bit here and see that am I using the right thing. Yeah. So the mistakes that I'm making here is very, very common, and you will make it all the time. And this is what we do again, like when we are typing code, 80% of the time we are fixing mistakes. Okay, it is actually working. I don't know why it wasn't working before. So it's perfect. So there are no mistakes here. It's actually working just fine. You see, when it is yellow, it's going to the else block because the costume number is 2 or 3. Purple is 3. When it is blue, it's 1. And that's why it's reducing the size to 50. So most of the job is done. And one important concept that we learned is if else block. Is that clear? Is if else block is clear? Because this is one very, very important concept. You have learned about normal blocks. You have learned about events. You have learned about loops. And now you have learned about if else. That's 80% of almost all the logic that is there in any coding language. So that's a big, big win. Now we are going to learn the last most important concept, and we would have learned actually majority of it that there is to learn. So this concept, please bear with me and try to focus, is known as variables and data. So what is variable? So we saw that we have to keep a score. How do I keep a score? We know that it's a number. Sometimes it will not be a number. Sometimes, for example, let's say you tell me your name and I'm building an application. You see here, There are so many examples all around. When you look at any website, you can see so many examples. It remembered my name is called Sarika, right? And it's showing my name here. So how does it know all of these information? It stores it in something called as variable. And the actual value is known as data or value or constants. Okay. So variables are proxies for some values. And you can change variables by using operations on it. If it is a number, you can do mathematical operations like 2 plus 2, 3 plus 4, 3 into 5, okay, for values as well as variables. So that is what we are going to do. We'll just take a very basic example and make a variable first and foremost. So my variable is going to be score because this is what I wanted. As soon as I make a variable, it shows up here. So it looks quite similar now to what we had before, but it's not incrementing it. So when should it increment? Whenever I click it. So when this sprite is clicked, we know it needs to go somewhere here. What is the operation we want to do on this variable? We want to increase it by 1. So there is a block that helps us do exactly that. Okay. So now when I click it, it increases. We have to choose the right variable. So it increases score by 1. Let's see if it works. Perfect. That was actually not that hard. So you understood the concept of variable. I'm keeping this value in a variable known as score because once I name it, I can use it in my code in different places. So that is important. And then I can do mathematical operations. These are known as operators. Basically +1, -1, multiplication. You can do many, many operations on this code. So I can do operations. Now, some of you had observed that when it is a blue block, we need to increase it by 2. And when it is not a blue block, we have to increase it by 1. How do we do that? Very, very simple. This block should go inside the if-else block. I'm sure you would have been able to answer that. Okay. So this one, remember, was for blue. So I'm going to change here by 2. And if it's not blue, then we are going to change it by 1. Awesome. So after a lot of hard work, we are here, but it's a very simple program and I am sure all of you were able to understand. Let's see if it works fine. Okay, so it's a blue one. Something is wrong. Like I said, you're always going to make mistakes, not a problem. The score is not increasing. Why? Because I did not choose the right variable. It is the score variable that we have to use. So let's go back. $16, $18. Okay. So it is actually changing it for the purple one, which is fine because I think my costumes are named in a different order and that is absolutely okay. So one take home exercise for you is how do you make the score increase by 2 for the blue one and not the other color. So I leave it as an exercise, another thing that you must try and resolve by yourself. So we learned 2 very, very important concepts. We learned about if-else blocks, which are known as conditional blocks. You put conditions inside them. You can do logical operations is what we call it. But basically what it means is you can do comparisons between 2 values. The values can be numbers or it can be variables that you can compare between. What are variables? Variables are items that store numbers or names or any strings under them so that you can use it in different places in the code and you can also do operations on them. All right. So again, I'll take a pause and I'll just do a quick check. Are you all able to follow? Please do a yes on the chat if you are able to follow so far. Awesome, awesome. Perfect. Thank you guys for keeping this interactive and paying attention. And I already informed you that it's going to be a little bit hard and I hope that you are all able to follow. I'm very happy about that. So here are the things that we learned. These are known as control blocks. Very, very important because life is not so simple. We have to do different things based on different conditions and we have to do some things all the time. So that's why in coding you have if else blocks and you have loops. We learned about both of them, and we also learned about wait when you want to slow down things. We learned about data variables and operations. Again, quick review, very quick review. Perfect. I'll take a pause here and we have to do a quick time check. I have two other activities, but we promised that we will keep this session short and we can do a part two. I had two more fun activities for you all to do, and I'll go through these, but we will not be able to do the activities live today because we want to do a quick time check and stick to the time. But before that, I'll hand over to Rohit, and he wants to share some information with you and take some input from you as well.
Thank you, Sarika. That was amazing workshop, and I myself was attending it, and I learned so many things, so many new things. So basically, some of you, when Litless was calling you, asked about what is Codju and why you guys are doing it. So I thought that we should take 5 minutes and we tell you that who we are and why we are doing it. And then there is a quick survey. So I'll show you. Yeah. So basically, me and Sarika, we are friends and now husband and wife. We were both in IIT Kanpur, and then she joined Microsoft. I joined another company, and then I came to Patiala and I started iQuest. It's a JE coaching, and we have been successfully running it for many years now. It's one of the best coaching out there in North India. Sarika was into software field, and she was making software for big companies, now leading teams and heading India. So because we deal with students, not only kids from class 7th to our pass out students who are in colleges, we came to know that things are pretty much the same as we used to do in our school time. So the computer education is it needs change. So we thought that we should be investing our time and have one of the biggest and one of the best uh, learning system that is out there in other countries, in our country as well. So we thought that we will build Codju, and we will build it in such a way that it should be a community style learning where teachers will also gain, they will upskill them, student will also learn, and they will learn not only from the books but by doing activities. So what we are doing is we are basically building Code Labs. Code Labs is an activity-based platform. So we will be reaching out to schools and giving them this Code Labs. I'll show you what we are trying to do. This is not what we want to build. It's just a prototype of the kind of platform we are advising. So suppose the student is in class 1, so he or she will learn in the class, then he or she will come in the lab and do the activities whatever he or she has learned in the class. For example, suppose in class 1 there is a chapter called keyboard. So generally we tell them this is a keyboard, this is this button, this is this button, but we think that the student should learn by practicing it. So let's say if the kid has learned keyboard in the classroom, in the lab he or she will learn typing. This is just a prototype. We have gathered the sources which are available for free on the internet. In our platform, everything will be our own, and students will be able to do so much of activities. Let's say this is the activity, this is typing activity. The student will come and he or she will start learning. Like for example, it is teaching J, F and space key. So he or she will keep his or her fingers and then start typing. So I am making mistakes and it is going to tell me how did I do. So there are many activities like this. So our assumption is that by having activity based curriculum along with the books, can be an awesome thing for students. So we want to have your views also on that. So this is one part of the Codju. Second part is the curriculum. We are building India's best books for students. By mean best books means we are bringing the curriculum which is required for them. It's required for them. So we will tell you about this later. So that's what Codju is all about. So we are working on it. It's not still out. It's not still out. We are trying to out it within 6-7 months. So that is Codju, and I would like that you guys contribute and tell us how the idea is and how can we improve it. So I'm sharing a Google form for the same. Kindly take out 2 minutes of time and fill it. So we will come to know that what do you like and how well we can make this platform. Sarika, if you want to add something.
Yes. So while you are, please take the 2 minutes to fill the survey, and I'll just add a little bit more color to what is the thought process behind claiming that we're going to build the best curriculum and the best books and the best platform for students. So there are two key points I want to say here. So the curriculum we have designed by looking at the curriculum which is relevant in US, Singapore, UK, Australia, all of these countries. What is happening there? And it has been happening for so many years. And we noticed and we felt really motivated to do this because there is so much of gap between what is happening in the US and what is happening in India. And we have so much potential. We have so many more kids and actually so many intelligent kids, because nowadays every day you hear a big company in US has a CEO who is of Indian origin, right? Google, Microsoft, everybody is being led by an Indian. But in India, for our kids, we may not have all the resources available to them just yet, but the talent is immense. So we looked at the best curriculums out there, and by looking at that and adding more to it, we created the curriculum by our own means. It has three areas. One is computer fundamentals, second is coding, and third is digital skills. Because not every child is going to become a coder in future, but they must know how to learn technology to create something, right? For example, video editing skills, photo editing skills, presentation skills. These are very important skills, no matter what they do. And it can open up a lot of entrepreneurship opportunities for them as well. Okay, so it's very important. It's not only for the privileged children. It's even more important for us to teach it to people with low means, students with low means, right? So that is one part, that the curriculum is solid. And the second one, like Rohit mentioned, is the activity based part. What we talked to a lot of computer teachers, and we came to understand that organizing activities with our limited resources in schools, we only have like so many computer systems, not so many students. It's very hard between all of that chaos and few machines to be able to organize activities, even though you guys want to do the best for the kids, right? Because there is no technology available today. So we are trying to simplify the lab activities, and we are trying to build it in such a way that students can go home, they can log into our website, and simply they can continue their activity and they can do further practice, right? So it is going to be very easy. If they want to learn some concept, there will be resources within the website itself. So that is the idea that I want to share, and your input will be extremely valuable for us. That do you think that this idea has merit? Will you be excited? What are the challenges do you see when you will want to adopt this in your classrooms? So please fill out the survey, and I hope you all have filled the survey. And one other thing that we are thinking about right now is that currently all of this system we are going to make available to students at almost the same price point as the book. So if a student buys a book at 300 rupees, they will get the book plus the platform at about 300 to 400 rupees. So we are not going to make it very expensive. Like some of you might know, there is White Hat Junior and whatnot nowadays, but they charge in lakhs. tens of thousands. It's very, very expensive. I don't think we should be doing that, and technology should be something that is accessible to every student. So for that reason, we are going to make it available at almost the same price point as a book. So please do share that. What do you think about that? Okay. So we will go back. We are at 12:08. I will continue with our workshop. We will not end so soon. So if some of you have other things to pay attention to, please feel free to drop off at this point. I am going to wrap up in no more than 10 more minutes. So I'm only going to take 10 more minutes, and we will be able to cover and end this at a good point, at a good conclusion point. All right. So focus back, please. Let's pay attention back to it. We left at a place where we understood what algorithms are. We understood and a lot of coding concepts, and we got familiar with a lot of different kinds of blocks, and we finished 2 activities. Here is a new concept again. What is debugging? So you saw that I made a lot of mistakes, and then I looked at a mistake. I identified the mistake. I thought about what could have gone wrong, went back to my code, looked at the code, found the mistake or the root cause, and then fixed it. This whole process is known as debugging, right? It's a very, very natural part of coding. You will never be able to write 100% accurate code in the first shot. So you have to be very good at debugging skills. This is also an important life skill, right? For example, in real world, we do debugging all the time, right? So let's say if I put my clothes in the washer, but somehow it's not working and the washing cycle did not complete, then we are going to go and debug it right away. Is the water available? Tank mein pani khali ho gaya kya? Is the electricity gone? Is the machine showing some error in the panel? Is the machine broken altogether? What is happening? You will find the root cause and then you will fix it, right? And not just this. If let's say somebody is angry with you, you try to debug why is that person mad at me? Did I not call them on the right moment? Did I say something bad, right? That's also debugging. So debugging is all around us at everything we do. Okay, it's a very important skill for coders as well as just for general problem solving. So here is a very, very quick activity for you that I have created. So I have created one activity, and this activity has a bug, which is a deliberate bug. So I have put a bug in there for you to find. So I'll go inside.
Sarika, kindly share the screen.
Oh, sorry. Oh, you guys should have told me. All right. So this is what is debugging, and this is the activity, and there is a deliberate bug in here. What is the bug? So I am not able to see the balloon. I have modified our previous exercise to add a timer. In this timer, what happens is when I click the green button, it starts a 5-second timer. You have to click as many balloons as you can in 5 seconds. But I don't see the balloon. Why don't I see the balloon? I'm going to show the code now. Can you see? Can anyone see? So the thought process behind debugging is, okay, I can't see the balloon. Like I'm trying to tell you the systematic way of going through a debugging process. What is the problem? I can't see the balloon. Why can't I see the balloon? Where did the balloon go? Did I hide it somewhere? I see that, okay, here is a hide block. So when I click run, at some point I have hidden it. So if I have hidden it, did I bring it back to be shown? I did not. So I need to bring it back to be shown. So if there is a hide block, there must be a show block. So I need to bring back and show it somewhere. I'm going to put it here, and you should think about it later on. Why did I put it here? So now my balloon is visible. And game over. Perfect. So after game over, I wanted to hide the balloon because you can't play anymore. But as soon as I restart the game by clicking run, I need to show the balloon. That's why I put it here. This is for restarting the game, and this is when the game is actually running. So this is a very quick introduction to debugging. And now we are on to our last activity, chasing the cat. In this activity, I'm going to simply show you the activity. We are not going to code it. So we are going to look at the code and we are going to understand the concepts. So there are very useful and actually very interesting key concepts in here in chasing cat. So let me actually show you what it is doing. I don't know if this will work because my video is on, but let me try it anyway. Can somebody tell me what's happening here? Can somebody guess what's happening? All right. So basically, the dog is appearing and barking only when I'm making any movement in my video. That is what is happening. So you'll see now. So now try to observe. If you look at my video, it only happens when I make some movement. Wait, let me restart it. So if you observe my video, I'm waving my hand. So when I wave my hand, the dog appears. So that's very interesting, and that you can do that with Scratch is also very interesting, right? Because like Rohit said, and a lot of people make this mistake in the beginning, Rohit said that it is programming language for kids. It's not a programming language for kids. It's a programming language for beginners. Okay, I need to stop this. Okay, perfect. So what we are going to do is we are going to look at the code of how I was able to achieve it. And with that, we will learn our last of the basic topics, which is user interactions and user inputs. So how do you take input from the user and do some interesting things depending upon what the user is doing, right? So, oops, sorry. So a lot of the times, for example, yeah.
Screen, I think. Yeah, fine.
Okay. So a lot of the times you are shopping on Amazon, you're doing a lot of things, and every time you have, give me 1 second. Yeah. So every time you have to give some input. This is going to keep barking. So let me actually stop this. So a lot of the times what will happen is that you will give some inputs, only then an application should behave, right? So in WhatsApp, you type a text message, in Amazon, you click on things. So there are many different kind of interactions. As software developers, we code for every single interaction. A very fancy website can actually detect a lot of different things that you do. For example, you're dragging your mouse, you're clicking somewhere, you're typing something, you're scrolling your page. All kinds of these things are known as actions, right? Or events. And then not this event, but click events, user events, okay? And here it is known as sensing. So using sensing blocks, you can basically do something depending upon what the user is doing. So is the user's mouse down? Is the user dragging something? Is the user touching a particular color? So these kind of things, and you can make very interesting games based on that, right? Another thing that I have used, which you can use, you have few more fancier blocks, such as video sensing, that you can use to make even more interesting kind of video games. So one of such video games that I have made is based on video sensing that I just showed you. So what I'm trying to do is that when you click the bell, my Scratch program will try to look at my video feed, figure out whenever I'm making a motion in front of my video camera, and take some actions when I'm making a motion. So the action that I want to make is that when I'm making any movement, the dog should be should appear on the screen and should bark and then should go away. So we know that how to do each one of these. So in our minds, we should think of the algorithm first, that what should happen to the bell, what should happen to the dog. We will not care about the cat right now. Let me delete the cat. Okay, and let's see. So there are two different sprites and two different things happen. So for the bell, the only thing that I want to do is that when I click on the bell, there is a sound that plays. That's fine, we know that. And then there are two things I want to do. I want to turn the video on, and after 30 seconds I want to turn the video off. So when I click the bell, only for 30 seconds it's going to track my video movements. Now what happens is, for the dog, I want to code that when I make any movement in front of my video, I want the dog to be visible, go to some random position, bark for 0.3 seconds, and then go away from the screen again. So very two simple things will put together make such a fancy code. So this is the last simple thing. You can also try to do it by, by a key press. So let's say if I'm doing, instead of this, very simple, let's say if I do a key press instead of video. So we saw the demo of video, so I'm not going to show that again, right? So I'm going to use my favorite block, which is and start click, right? And this is not going to work because I need to be checking for this condition all the time, because otherwise it's only going to check for it once, and that's not good enough. It needs to be checking for it again and again. So now let's see. So now I am pressing the space bar, and the same thing is happening on space bar press. So we learned how to take user input in terms of key presses, video inputs, and you can also take text inputs and say hi, hello, etc. very easily. So I'll thank all of you for sticking together, also staying around for 10 more minutes and showing the patience until now. But I hope this session was very useful for you to learn the basic concept of Scratch and also advanced concept of Scratch. And here is a quick review of all that you learned. You learned about sprites and backdrops, blocks, script, if-else loops, variables, operators, user input, and sensing. So much in such a short amount of time. You also learned about how to build a Scratch animation, how to build a Scratch game. You also learned about what are algorithms and what is debugging. So that's a lot to cover in such a short period of time. Thank you so much. And we will meet in next 2 weeks to go and dive into Python. Okay. Thank you very much, everybody.
One more thing. That was a great session, ma'am. And one more thing, we have made one 5-question test to check what you all have learned. Also, I will be sending you the presentation and the recording as I sent last time. So kindly take the test, and those who are going to take the test will get the certificate immediately. All right. Thank you so much. And we will see you on 18th of September with Python coding and the same session like this. Thank you.
Thank you so much. Enjoy. Bye, everyone.